Hi, this is Mrs. Bajan, and I am going to help you learn how to solve equations and inequalities with absolute value today. So, as you will recall, absolute value is the distance from zero on a number line. So, distance is never negative, distance is always positive, right? If you leave from your house to drive to campus, you may drive 5 miles. If you leave from campus to drive back home, you've still driven 5 miles. You've not driven negative 5 miles. So, distance is always positive distance. So, for any number a that is greater than 0, and an algebraic expression x, if the absolute value of x is a, then x could be a or x could be negative a, right? Because if a is negative in the absolute value bars, when it comes out, it becomes positive. So for example, if we are to solve for x here, for an example 1, we have the absolute value of x is 3 halves. So x could be 3 halves, or x could be negative 3 halves. Because think about it, if we substitute 3 halves in, you'll get the absolute value of 3 halves as 3 halves, of course. But also, if you substitute negative 3 halves in, the absolute value of negative 3 halves is also positive 3 halves, which satisfies the equation. So for example 2, the absolute value of x is negative 2. Well, this is not true. The absolute value of anything is never negative. So this is not true. So the answer here is no solution. So to solve an absolute value equation, all you're going to do is isolate the absolute value expression, and you're going to use the absolute value property to separate the equation into two new equations without absolute value bars. And you're going to solve each equation. And to check, you'll plug both values back into the original equation. Screenshot this page or take a moment to pause the video to write these notes down. So for example 1, we have the absolute value of 2x minus 1 minus 5 equals negative 3. So step 1 says to isolate the absolute value expression. So we need to get this absolute value expression alone, by itself, on one side of the equation. To do that, we need to get rid of that negative 5. So let's add negative 5 to both sides. So now we have completed step 1, which is to isolate the absolute value expression. And now we can use the absolute value property to separate the absolute value expression into two new equations without the absolute value bars. So we're going to have 2x minus 1 equals 2. And we'll also have 2x minus 1 could equal negative 2. Solve for x. And solve for x for the green side as well. Okay, so now we have two solutions. The last step is to substitute these back into the original equation and see, does it check out? Will the left side equal the right side? So if we check for the first equation, we have the absolute value of 2 times 3 halves minus 1 minus 5 equals negative 3. Take a moment to see if that works out. You will end up with 3 minus 1 minus 5 equals negative 3. The absolute value of 3 minus 1 is negative 2. I'm sorry, the absolute value of 3 minus 1 is the absolute value of negative 2. And so we have positive 2 minus 5 equals negative 3, which checks out. And check your other answer as well. we'll have negative 1 minus 1. Yep. The absolute value of negative 1 minus 5 equals negative 3. And then we'll have negative 2. The absolute value of negative 2 minus 5 equals negative 3. 2 minus 5 equals negative 3, and this is true. So both answers are good. You want to check both of your answers because one of the answers may not be correct, and then your solution would only really have one. So be sure to check your solutions. You take a moment to solve this one on your own. Remember to first isolate your absolute value bars. So you need to get rid of this 5, and also you do need to get rid of this negative sign. And then separate this absolute value expression into two separate equations, setting it equal to the positive side here or the negative side. And lastly, don't forget to check your solutions. So you can see I have isolated the absolute value bars. I first got rid of the 5 by subtracting it from both sides, and then divided the entire equation by negative 1. So this is a positive absolute value bars equals positive 3. Take your algebraic expression within the absolute value bars and set them equal to the positive 3 and also to negative 3 and solve for x. You can see I've solved for x on both of these sides. Here I subtracted 3, they were subtracting 3, so I added 3 to both sides and then divided both sides by 4 and simplified my fraction. Again, they're subtracting 3, so I added 3 to both sides and got 0. 0 divided by anything is always 0. So the last step is to check your answer. So we will use the original equation to check the answer. So substitute your solution in and see, does the left side equal the right side? After you have checked both sides, you will see that yes, both solutions do check out. So we did a good job. So these are the two solutions. X can be 3/2 or x can be 0. What if we have an absolute value inequality, not an absolute value equation, but an inequality using greater than or less than, greater than or greater than, less than, greater than or equal to, less than or equal to, or not equal to? The solution to an inequality is a set of numbers. We'll write the solution in interval notation. So if we have an expression, absolute value of x, whatever the equation is, if we have the absolute value of anything is less than a, then x will be between two given numbers. If we have the absolute value of an expression is greater than a, then we will have options. X could fall into this interval or this interval. So it's silly, but the way I remember this is to say if it's less than, and you're using and, which is between two given numbers. Or if it's greater, that's when you're using or, greater, or. So let's solve these and write the solutions in interval notation. So here we have less than. So x will be between two given numbers. X could be between the negative number that they give us, and x can be between the positive number. If it's greater than or equal to, then x is going to be greater than or equal to the given number, or less than or equal to the negative number. So greater than or equal to the given number, or less than or equal to that negative number. And of course, you must write your answer in interval notation. So take a moment to pause this video and write these answers in interval notation. There are your solutions in red. So let's do this one here. We have this absolute value is less than or equal to 14. Less than, and. So that means it's going to be in between. So we're going to have the expression is in between the negative solution or the answer and the positive answer. Like we learned when solving inequalities, you simply solve this like you would an equation, but whatever you do to one side, you must do to all three sides. So if we divide by 3, we have to divide everything by 3. So x is between negative 19 thirds and positive 3. Take a moment to pause this video to write your answer in interval notation. There's your answer in red. Here is the last problem. Take a moment to pause this video and solve this one. This is greater than 4, so greater, or. So we will set this greater than the positive answer, and then we'll set it less than the negative answer. Take a moment to do this and write your answer in interval notation. So I took the expression within the absolute value bars and set it greater than the given answer and then less than the negative answer. Multiply both sides by 5 and add 2. Same here, multiply both sides by 5 and add 2. So here are our solutions. In interval notation, it's given here. It is an or statement using the union. If you have any questions, email me.